Hey guys, today I want to present the solution for the Asian Pacific Math Olympiad 2019 problem 1. At first, let's have a look on the problem statement. We are asked to find all functions from the positive integers to itself such that a squared plus f of a times f of p is divisible by f of a plus p for all positive integers a and b. So we can write down f of a plus p divides a squared plus f of a times f of b. So let's call this 1. Normally, if we have some divisible properties, then it's always difficult to handle sums. Therefore, we want to get rid of the sum on the left hand side. And thus, the idea is to put in b equals f of a in 1. So we get 2 times f of a divides a squared plus f of a times f of a. Now, this means that also f of a divides the right hand side. So f of a divides a squared plus f of a times f of a. And now, since here's a factor f of a, we know that f of a divides a squared. Now, it would be nice if the number of divisors of a squared is a low number, because then there are not too many options for f of a. So we choose a equals p, where p is a prime number, and we get that f of p divides p squared. And since the only divisors of p squared are 1, p, and p squared, we know that f of p is equal to 1, or f of p is equal to p, or f of p is equal to p squared. And now, let's move this to the top of the blackboard and have a look which of these cases are possible. Now, in order to find something out about f of p, we can put in p for a and b into equation 1. And this gives us that f of p plus p divides p squared plus f of p squared. Now, let's have a look on the first case, that f of p is equal to 1. Here we have that 1 plus p divides p squared plus 1. But since we also know that 1 plus p divides p squared minus 1, 1 plus p must divide 2. So 1 plus p divides 2. And this is clearly impossible, since p is a prime number greater than or equal to 2. Now, in our second case, f of p is equal to p. And here we have that 2 times p divides 2 times p squared. And this is possible. So this case can be true. And our last case is that f of p is equal to p squared. And here we have p squared plus p divides p squared plus p to the power of 4. And now we can factor both sides and get p times p plus 1 divides p squared times p squared plus 1. But since p plus 1 and p are relatively prime to each other, we know that p plus 1 must divide p squared plus 1. And this is a contradiction because of the same argument than in our first case. So this is also not possible, and f of p is equal to p is our only possible case. Now we want to use the fact that f of p is equal to p, and therefore we want to put in p for a or b into this equation. At first, p equals a gives us p plus b divides p squared plus p p times f of p. And if we put in p equals b, we get f of a plus p divides a squared plus f of a times p. Now we see that in this equation we can factor out p on the right hand side, and therefore this might be the better choice to work with. So we take this one and get p plus b divides p times p plus f of b. Now, since p is an arbitrary prime, we can use p in such a way that p does not divide b. Therefore, p plus b is relatively prime to p, and so we can say that p plus b divides p plus f of b. Now we can subtract p plus b from the right hand side, and so we get that p plus b divides f of b minus b. But now we can choose p large enough, and therefore p plus b is greater than f of b minus b. So p plus b is greater than f of b minus b. But this means that f of b minus b must be 0. So f of b minus b is equal to 0, and therefore f of b is equal to b. So f of b is equal to b is our only possible solution, and now it's left to prove that f of b is equal to b works. In order to prove that f of b is equal to b works, we can put in f of b equal to b in our two terms here. So we get that f of a plus b is equal to a plus b, and this must divide a squared plus f of a times f of b, and this is equal to a squared plus a times b. Now we can factor out an a, so this is equal to a times a plus b, and now we have the factor a plus b on the right hand side, and therefore indeed f of b is equal to b is in solution.